Greetings all. Today we're going over installing a highly available horizontally scaled GitLab setup. It'll match a lot of what you're seeing here, with the exception of there will only be one load balancer, two application servers, and there will be three Redis servers. This will be done on GitLab 11.11.3, and we'll be installing GitLab on several servers using the omnibus install method you can see here, with the exception of we're not going to be passing in an external URL. So we're going to go ahead and start on part one, which is console. Now I've already got GitLab installed on the three of these, and I've modified my etc host file to contain entries for all the servers that will be there in the final process. So to begin, we're going to go ahead and edit the etc GitLab RB. We're going to go ahead and delete what all's there because we're going to put in new information here. And we're going to paste in our information here. The first entry there sets the console role, which will basically tell it disable everything that's not console. And then we get to our console configuration, setting this up as a server, binding it to an address. I'm going to go ahead and delete these other two right here. And then we're telling it the retry join to use all three console servers, which will be console 1, console 2, and console 3. And we're also telling it to disable auto migration, since that's not something we want console doing. With that in place, we're going to run GitLab CTL reconfigure. We'll go ahead and do this on our other servers as well. Edit the GitLab RB, delete what's there, paste there. And this is our second server, so we want to keep that one. And GitLab CTL reconfigure. And we'll go ahead and do it on our third one as well. Delete what's there, paste our configuration, keep the third server, and GitLab CTL reconfigure. Now we're going to need to let this complete, so we'll let this complete and then get right back to it. With that configured, we can go back to our first server, and we want to kind of do a checkpoint here, so we're going to check to make sure that it can talk to the three of them. So we're going to run opt GitLab embedded bin console and then pass in the members argument. Doing this, we should see console 1, 2, and 3, their IP addresses, the port they're bound on, and that all three are alive. This is important. Now, before we proceed here, we're going to want to go ahead and generate a console password. So what we'll do is paste in this. It's GitLab CTL pg-password-md5, and then GitLab console is the user that'll be used. For this example, we're going to use password as the password here, and that'll give us a hash. We can run this on all three to confirm that they all give us the same hash. They very well should. And now we've got our hash. We're going to need to save this for later steps, so make sure you copy that somewhere to your clipboard. With that and console confirming that all three members are there, never hurts to go ahead and run this on all three servers just in case, to make sure they're all giving the same information, and they are. So we are good with console and ready to proceed to the next stage. Greetings all, this is part 2 of the GitLab highly available horizontal scaling tutorial. Once again, we're going to be going with this installation, with the exception of there will be one load balancer, two application servers, and three Redis servers. Today we're covering the databases and PG bouncer. I've already installed GitLab on all of them, following the omnibus instructions, with the exception of not passing in an external URL. So let's go ahead and get to it. Once again, GitLab version 11.11.3. So we're going to go ahead and start on PG bouncer. Once again, we've set up the host file to talk to one another, so we have all that information. So we're going to go ahead and start by generating a password hash that we will be needing for the other installations. To do this, we'll do GitLab CTL pg-password-md5, and then GitLab will be the user. And once again, for this tutorial, I'm going to use password as my password, which I know, terrible. We're also going to need to generate one for the PG bouncer user. Password, and we can run this on all four of our servers, PG bouncer and the three database servers, to confirm they will have the same thing. So we're going to go ahead and edit the GitLab RB, delete all that because we're going to paste in our own configuration here. Now this configuration is going to look like this. What we're doing here is disabling all components except Postgres and rep manager and console, which is what the Postgres role will do. We're also going to set up the configuration to listen on all interfaces, to tell it hot standby is on, to set the wall level to replica, and the shared preload libraries, we're going to load up the rep manager functions. We're going to tell it to not do auto migrations because it's not something we want. Under console, we're going to tell it to use the PostgreSQL services. We're then going to go ahead and replace these with what we need. Now, I've already set up the hashes to what we generated previously, but you want to make sure the PG bouncer and SQL user password are what they need to be. We're then also going to set the max wall senders. This needs to be the number of database nodes plus 1. As we have 3 nodes, that makes this value 4. Down here, we're going to insert the trusted seeders for both of these values. It should be localhost /32, and then you need to do whatever seeder group is going to cover all of your network. In this case, since a lot of it will be talking internally, we can use 10.136.0.0/16, which will cover pretty much everything in the 10.136 address space. And then under here in the console configuration, we're going to need to bind it. So this is the first server, so we only need to bind it to this first one. And then we're going to tell it needs to be retrying with console 1, 2, and 3. Now, as this is the first one, it's going to be master and initialization, so we want to leave this commented out for now. With that in place, we're going to want to go ahead, save it, and do GitLab CTL reconfigure. We're going to go ahead and move on to our secondary node, GitLab RB, delete what's there, paste this in. And much of this is the same value here. We're going to keep only the second server IP here. And as this is a secondary, we want to go ahead and make sure master on initialization is set to false so it doesn't automatically try to promote itself to master. With that in place, we're going to do GitLab CTL reconfigure and move on to our third one. GitLab RB, delete what's there, paste our values. And we only need the third server this time. And once again, as this is a secondary, master initialization needs to be false. And save that and do GitLab CTL reconfigure. And we need to let this complete, so we'll go ahead and do that. Great, with all 3 configured, we can go back to our primary node, PG1, and we're going to need to do a few additional things here. So the first thing we want to do is access the database, the GitLab HQ production, using GitLab-PSQL, and then pass in that -d flag to specify the database to connect to. Doing that will give us a Postgres prompt. From here, we're going to do create extension PG_TRGM semicolon. Now, in theory, this should already exist, and if it does, great, we're done with that. If it doesn't, this will create it for you. Go ahead and quit out of this. And next, we're going to need to ensure that rep manager is showing the cluster properly. So GitLab CTL, rep manager, cluster show. Doing that should tell us that the master, PG1, and then we can see the host and all that fun stuff. The key here is seeing that everything is upstream and good to go. Next, we need to go to our secondary server, and we need to go ahead and set it up as the standby. So to do that, we're going to do GitLab CTL, rep manager, standby, set up the name of our master. And I'm going to pass the -w flag in there so we don't have to wait 30 seconds. While it's doing that, we can go ahead and do it on the third secondary as well. We're going to go ahead and need this to complete, so we'll wait for that. With that done, let's check on the third. Third is done as well. So with all of those set up, we should be able to rerun the GitLab CTL rep manager cluster show. And now we should see that we have the master and then the 2 standbys. The key here is everything is showing alive. We're not seeing any errors here. We can run that on all 3 servers and see the same details. This is a sign that we're in a good place. So now we're going to work on PG Bouncer. We're going to go over here and edit the GitLab RB, and you guessed it, delete everything that's there because we're going to add our own configuration. Now there's a bit more here. So we're going to need to copy this over here and paste it. What we have here is we're disabling all roles, all components except PG Bouncer and console, which is specified by the PG Bouncer role. Where they're going to set the PG Bouncer administrative users to PG Bouncer and GitLab console. We're then going to configure the console agent watchers to watch the Postgres SQL service. We're then going to need to put in our password hashes. Luckily, I've already done that. And then we're going to set up our console configuration to bind it to itself and then tell it to retry join on console 1, 2, and 3. With that in place, we can do GitLab CTL reconfigure. We're going to need that to finish, so we'll wait for that. With that done, we now need to go ahead and create a password file. We're going to do that via GitLab write -pg pass, tell it the host is localhost, the database is pg bouncer, the user is pg bouncer, and the host user is GitLab console. Hit enter there, and once again, password. I know, terrible, but we're going to do that anyway. Next, we need to confirm everything is up and running, so GitLab CGL, pg bounce, console. Doing that will ask for the password. I'm going to give it that terrible password there, and I'm going to do show databases, semicolon, show clients. And here we should see output like this. We see our GitLab HQ production, our host PG1, because that is our master, sorry. And then down there, we can see that PG Bouncer is showing that it has active clients. With that, we can go ahead and do /Q to quit out of there. And we are done with that. Next, we'll get to setting up Redis and Sentinel. Greetings all. We're resuming our GitLab highly available horizontally scaled setup. This is part 3 where we'll cover doing the Redis servers and the Sentinel servers. This is matching much of what you see here with the exception of there will be 1 load balancer, 2 application servers, and 3 Redis servers. This will be done on GitLab 11.11.3. And all the Redis servers have already had GitLab set up on the omnibus instructions seen here, with the exception of we didn't pass in an external URL. So let's go ahead and get started. To this, we're going to start on Redis 1, which will act as our master Redis and master Sentinel server. I've already set up the etc host file, which you can see here, so it can talk to everything else. So with that, we are going to go ahead and start by editing the GitLab RB file. We're going to delete everything that's there. And then we're going to paste in some very specific configuration for the master server. So what we're here is we're specifying the roles as Redis master role and Redis Sentinel role, which will disable all components except what the Redis master and Redis Sentinel need to proceed. We're binding the IP address to the internal IP address. Big note here, while generally you could use a public IP for Redis, it is not advisable. There are security issues in play with that. So you do want to try to bind it to an internal IP address whenever possible. I'm specifying the Redis port, but that is the default. And then I'm going to tell Redis its password is password, not very secure, which is why we're putting this for sure on an internal IP address. We're also going to specify the master IP address, which is Redis 1 in this case. And we're telling it not to do auto migrations. We don't want it doing that. And we're also binding Sentinel to that, the internal IP address. Now down here, I'm setting the quorum for Sentinel to 2. Quorum's a bit of a complex concept, but basically there's kind of 2 different ways you can tune it. If a quorum is set to a value smaller than the majority of Sentinels we deploy, you're basically looking at it being more sensible to master failures, so it can easily trigger failover. Whereas if you set it to a value greater than the majority, we're looking at Sentinel being able to failover only when a very large number, larger than the majority, of the Sentinel servers are in agreement that the master is down. As we have 3, I'm setting it to 2. So I'm actually going with the second thing of I want 2 of these servers to agree that the master is down before we conclude it's actually down. Now with that, we're going to do a GitLab CTL reconfigure. If I can type, reconfigure. And we're going to wait for this to complete before we even touch the other 2 because we really need to configure the master setup first. So we'll wait for this to complete. With that completed, we need to tell it to skip the auto reconfigure. So to do that, we simply have to touch the file etc GitLab skip-auto-reconfigure. Now with that, our Redis master Sentinel master is set up. So we can go on and move to Redis 2 and 3, which will act as our secondaries. Now, once again, we're going to edit GitLab RB. We're going to delete all of this, and we're going to paste in our new values. Now, some of this will seem very familiar from the master, in that we're specifying the roles, but this time we're giving it the Redis slave role. That tells it it's a secondary. We're binding it to its internal IP. Again, do not use public. We're defining the Redis port. The password is password. Master IP will be the IP address of your first Redis server, the master we just set up. We're telling it not to do auto migration, and then we're telling Sentinel to bind to the internal IP address. Once again, we're setting quorum to 2 to tell it that when 2 of these servers agree that master is down, we can do a failover. So we're going to go ahead and do GitLab CTL reconfigure. And while that works, we're going to go ahead and set up Redis 3. Once again, we're going to edit GitLab RB, delete everything, and paste it in here. And this time, we need to take away that, and we need to take away that to bind it to the correct one. But other than that, the settings are the same. So we're going to do GitLab CTL reconfigure, and we need to wait for this to finish. Now with that finished, we need to tell it to skip the auto reconfigure, so we will once again touch that file. We're going to go ahead and do that on 2 as well. With that, our Redis Sentinel setup is now complete, so we're ready to move on to the next steps, which will be our NFS and load balancer, which we'll be using HA proxy for. Welcome back. We're continuing our setup of a highly available horizontally scaled GitLab instance, following the diagram you see, with the exception of we'll have 1 load balancer, 2 application servers, and 3 Redis servers. Today we're going to be covering the NFS server and the load balancer setup. This is on GitLab 11.11.3, but what you're about to see kind of works for almost any GitLab version. So to get started with the NFS server, what we're going to need to first do is set this server up to be ready for NFS. To do that, we need to first go ahead and disable leases enabled. We can do this by simply echoing in a 0 into this file. From there, we can go ahead and do a sysctl-w to set it up right now for our session. And with that, we're going to go ahead and install the NFS kernel server package. With that complete, we need to go ahead and enable the kernel module NFS. To do that, we can do modprobe NFS. With that done, we want to go ahead and enable that systemctl service by doing systemctl enable nfs-kernel-server. Now with this, we want to go ahead and make the directory we're going to be working with, which will, in this case, be home GitLab. Now after this, we're going to need to go ahead and edit etc exports. We can go ahead and delete what's here, because we don't really need that. And what we're going to instead do is paste in the configuration we do need, which is telling it the folder we're going to be working with, home GitLab, and then the IPs of the servers accessing it. In this case, it'll be Web 1 and Web 2, so there's the internal IP addresses for that. And then we're going to pass in these mount options, read, write, sync, no root, squash. With that, we can go ahead and save the file, and we're going to go ahead and kick the NFS service to apply those changes. Now next, we need to go ahead and make some folders before we go any further. So we're going to make the .ssh folder. We're going to make the GitLab Rails uploads folder. We're going to make the GitLab Rails shared folder. We're going to make the Get Data folder. And we're going to make the GitLab CI builds file, or folder, sorry. These are core components of GitLab, so it's important that they already exist to help prevent any issues. Now with that, NFS is set up so we can move over to our load balancer. Now with the load balancer, we just simply need to set up HA proxy. So we can do an apt-get install HA proxy and wait for that to complete. With that completed, we want to go ahead and enable that systemctl service so it's there on reboot. And now we're going to go ahead and edit the etc HA proxy config. Now with this, we need to go ahead and paste in our configuration. So I'm going to delete everything since I have the globals there, but you can mostly leave those the same. The key here is we're going to set up a front end. We're going to call it local server because I'm not very imaginative. We're going to bind it to the public IP of the HA proxy server and to port 80 with mode HTTP. And we're going to tell it the default backend is my web servers. Then we're going to set up a backend my web servers, mode HTTP, balance round robin, option forward 4, set up some headers. We're going to set up a check, and then we're going to set up the servers, Web 1, Web 2, and give them the internal IP addresses as well. Now, a lot of this is highly configurable, so you can change this to fit your needs. With those settings in place, before we do anything, we want to make sure that they're valid. So we're going to call HA proxy-c-f and then give it the config file. And we should see configuration file is valid. With that, we can go ahead and restart the service to apply it. And with that, we're done with our HA proxy and our NFS setup and are ready for the next step, which will be our application servers. Welcome back. We're completing our GitLab highly available horizontal scaling setup today with the application servers. We're following this setup with the exception of 1 load balancer, 2 application servers, and 3 Redis servers. I've already installed GitLab on both application servers following these instructions, with the exception of I didn't pass an external URL into the actual install commands. So let's get started. Now on both of these, I have edited the host file to contain all the various information we're going to need. Now, as we're going to be using NFS, we need to go ahead and install the NFS common package. We'll wait for that to complete. With that completed, we now need to go ahead and pre-make some of our folders like we did on the NFS server. So we're going to make get data. We're going to make the .ssh folder. We're going to make the GitLab Rails upload folder. We're going to make the GitLab Rails shared folder. And we're going to make the GitLab CI builds folder. And we'll need to do that on both of these. So let's go ahead and do that. There's our CI builds. There's our Rails shared. There's our Rails upload. There's our .ssh. And there's our get data. Now with that in place, we need to edit the etc fstab file. We're going to keep the values that are there because they're pretty important. And what we need to do is go ahead and paste in some settings here. Now what this is going to do is point to our NFS server, the folder it's going to use on the NFS server, and then where it's going to use it here. We're going to use the NFS4 version, and then we're going to pass in a bunch of options. I'm going to go ahead and save that and do that on both of these servers. fstab, keep those, paste that in, and save. Now we need to go ahead and mount these, so we can do sudo mount-a to mount everything in the fstab file, and we shouldn't get back any errors. And then we can confirm these mounted by running mount, and we will see set lines like this for our NFS setup. Now with this in place, we need to go ahead and edit the etc GitLab RB file. We'll go ahead and do this on server 1. We're going to delete all of that because we have our own settings. And then we're going to go ahead and copy everything that we're using. Going over this quickly, we have the external URL, which is going to point to my actual public. This is actually the load balancer, but we're going to set the mount point to var-op GitLab get data. This tells it basically, yeah, don't start if that NFS mount's not available, since that's all of our get data. We're going to give it the application rule to tell it that it's acting as an application server, so it doesn't need things like Redis and Postgres. We're going to make sure Nginx is enabled, and we're going to make sure that Postgres is disabled. We're going to pass in the Postgres connection details. Now, you want to actually connect it to the PG bouncer, so make sure the host is the IP address of PG bouncer, in this case, internal, the port, and then whatever password you're using, password in my case, and then the encoding, I'm using Unicode. We're also then going to pass in the Redis information. The master name is GitLab-Redis, and the password is password. And then we're going to set up our Sentinel setups. This is basically going to be the host IP of all of them, and then whatever port you configured, in this case default. Now to ensure there's no permission issues, we need to set the UID and GIDs of various users. So the default user, which will be Git, is going to use 9000, the web server will use 9001, and the registry is going to use 9002. And we want to tell it not to perform auto migrations. We're going to go ahead and save that, and we can do a GitLab CTL reconfigure. And while that runs, let's go over to Web 2 and do the same thing. GitLab RB, delete all this, and paste it in. They'll both use the exact same settings, which is super convenient here. Now we're going to save this, but we're not going to save this, but we're not going to reconfigure quite yet. So let's go back to 1 and wait for that to finish. Now with our first web server configured, we're going to go ahead and set up the database. To do this, we're going to do GitLab-rake, GitLab:/DB:configure. And we'll wait for that to finish. With that completed, we're almost done here, but we need to go ahead and cat the etc GitLab-secrets.json file. And we're going to need to copy all of this over to our secondary server. So we'll go ahead and copy this and go over to our secondary server. And then we're going to edit GitLab-secrets.json and paste in those values. That we're going to save it. And now we should be good to go ahead and configure. But first, we're going to go ahead and tell it to skip the auto reconfigure. We don't want the secondary doing that. And we'll go ahead and run the reconfigure and wait for that to finish. With that completed, our highly available horizontally scaled setup is complete. So we should be able to go ahead and go to our thing. Just to make sure cache doesn't come into play, I'm going to go ahead and open the incognito browser and go to getlab.jcollier.com. With that, it loads and tells us we need to create a password for our account. So I'll create a password, and then I can sign in as the root username using that password I just created. Now, just to confirm everything's working right, I tend to recommend we go ahead and create a project. It doesn't need to be anything super fancy. We'll just call it test, and we'll make it public and give it a README. This should create some files and database entries. With that, we can see the project was created, so we know that our instance is working correctly. And that's all there is to it.